Well, it is my pleasure this morning to introduce our keynote, who is Richard Walje, the president of Rocky Mountain Power, which is a part of Pacifica Corporation. That's a position that he has held since 2006, about 3 years now. But he has very deep roots in the power industry. He started his career as a journeyman lineman, decided to become an engineer, choosing electrical engineering after first rejecting chemical engineering, he tells me. Good decision, I think. After becoming an engineer, he worked for General Electric for a number of years in their high voltage equipment area, then had the opportunity to return to Utah and work for Utah Power and Light, and has been with that organization and successor organizations ever since, basically, as I understand it, including a stint, however, with Scottish Power, which had some ownership rights in there along the way. Would like to thank you, first of all, for being a sponsor of this meeting. We very much appreciate that, as Gene indicated. I will also tell you that he admitted that he is a former IEEE member, former member of the Power and Engineering Society, but in the spirit of member get a member, he has just told me this morning he is going to re-up. So we thank him for that. Rich, we welcome you. Thank you very much for being here.
Okay, is this working? Very good, thank you. Well, after my presentation, you may want to rescind my my membership application, but we shall see. Well, it's my very great pleasure to welcome you to Salt Lake City. It is a wonderful place to live. I hope some of you are going to be here long enough to take advantage of what we call the greatest snow on earth. I might also say we have the greatest sandstone on earth. So if any of you have ever had the opportunity to visit the Red Rock National Parks in the southern part of the state, you'll know what I'm talking about. So if you do get a chance to ski, you're a skier, this is the place to ski. We're going to talk a little bit about our company. We have a long history of innovation, particularly in the power engineering area. I want to really emphasize with you that I think the future economic health of this country depends on the people in this room and the other power engineers in particular, and I'll explain why that is. I also think that there are going to be many more career opportunities for people in the power engineering part of our business, as well as electrical engineers in general. And so that's, and I'll talk a little bit about how we're responding to the changes in policy that we see either that have been made or are going to be made as we go forward. One of the things we're very proud about in Utah Power and Light is that Salt Lake City was the 5th city in the world to receive central electric lighting, and that was behind London, New York City, San Francisco, and Cleveland. So I don't know why Cleveland and Salt Lake City wound up being put among those other more cosmopolitan cities, but there you go. Utah Power and Light was formed and incorporated, even though there were some predecessor companies back in 1912. And so as Dr. Day pointed out, my roots run pretty deep because in 2012 we will have been a company 100 years, and at that point in time I would have been associated with this company 40% of that 100 years, though I hate to admit that, but that is the case. We also had one of the first high voltage transmission lines, 57 kV, coming out of our Telluride properties in southwestern Idaho. And over the course of time, like most electric utilities, investor-owned utilities, we are an amalgam and consolidation of several smaller utilities when those utility companies were really based very localized because the transmission system hadn't really been invented yet that early on. Again, I won't go too far into this, but we've been expanding. We were able to build another one of the first high voltage lines out of the Glen Canyon Dam project, bringing that hydropower into the Wasatch Front, as we call the area here along the Wasatch Mountains. And we've been growing pretty rapidly. Utah is the fastest growing state in the nation as a percentage basis of population, which drives electric load. And we have gone from about 280,000 customers in '68 to about 770,000 today. So that's, as I'll elaborate, our big challenge. Well, one of the things that we're also proud of is our contribution to the power engineering area. We were one of the first utilities to use electronic distance relays, Schweitzer relays, on our transmission lines, because we somewhat pioneered the notion of a mine-mouth coal-fired generating plant using high-voltage transmission to a load center. So not only did we have to figure out how to protect and relay on that system, we also had to do a little bit of innovation on high-voltage equipment. So we were one of the first entities to use pre-insertion resistors on high-voltage electrical equipment. So we're pretty proud of that history. We have somebody in our midst, Dennis Hansen, one of our best engineers, who's put together a power quality handheld tool using PDA technologies. We've had somebody in our group, Mark Sampson, actually work on the physical side of transformers, where we were finding delivered transformers and rebuilt transformers coming in, not being blocked and tightened down tight enough so that they'd fail on large through currents. So we've actually put in some procedures that I think are being adopted industry-wide. Josh Jones, one of our newest engineers, has done some work on using information technology and individual customer outage history to improve our maintenance practices. And then Craig Quist, who will be speaking later on, is becoming an expert at wind integration. And wind integration turns out to have a few more challenges than people think, I think, on the face of it. So lots of contributions we've made to the industry. We're part of Pacific Corp. Pacific Corp was formed in 1984 when Utah Power and Light merged with Pacific Power and Light. We were acquired by Scottish Power. As Mr. Day pointed out, I wound up being the Chief Information Officer of that organization for a while. And then we were acquired by Mid-American Energy Holdings Company, which is a consolidated subsidiary primarily held by Berkshire Hathaway, or Mr. Buffett's organization. This is just a brief overview of Rocky Mountain Power. This is sort of the sales and marketing pitch. We have about 1 million customers in 3 western states. We have a service territory of about 110,000 square miles, one of the larger service territories in the country, about 3,750 employees. So it's the size of our organization. This is the obligatory marketing slide. We do have among the lowest rates in the nation, and that is a direct result of the predecessors to my position, their planning acumen, their foresight, and this use of, as I said, central mine-mouth coal-fired generation delivered to load centers by pretty long transmission systems. That's a real blessing today because we have among the lowest prices in the country. We're in the bottom 20% according to EEI, but it also presents us with some unique challenges as we think about CO2 management perhaps going forward. Our biggest resource challenge is really presented in this slide right here. On your right, or your left, you'll see this is the demand curve for the Wasatch Front. Here along from about Ogden, Utah to Provo, Utah. This does not include our industrial customers, but commercial and residential electric consumption is growing about 2.5% along the Wasatch Front, but our peak demand is growing closer to 4 to 4.5%. That's a direct result of our customers converting from something called evaporative coolers or swamp coolers. Anybody know what those are? You trickle a little water down a burlap bag and you blow some wind through it, and theoretically the evaporation cools off. Having grown up with one of those, I can tell you in the hottest days the family would huddle underneath the hole in the ceiling trying to stay a little bit cool. Well, now as we've become more affluent and our electric prices have remained a real good deal over time, there's a lot of conversion to central air conditioning in the state. Utah also leads the nation in average square foot house size. Probably a little known fact that Davis and Utah counties have the largest mini McMansions, I guess they're called, in the country. And that has actually just started recently, so it hasn't always been that way. And so that's really pressuring us to figure out all sorts of innovative ways to meet that peak. And as electrical engineers, you all know that we have to have the capacity to meet that demand. And as an electric utility, by law, we're obligated to meet that demand. Anybody who comes into our service territory has the right to connect to our system if they meet the obligations. So we have to figure out how to not only meet one of the fastest growing loads in the nation, but also one of the spikiest loads in the nation. The graph on the right shows our deficit in generation. If you extrapolate out that growth on a regular sort of the economy we had, Utah had one of the most robust economies in the country and still actually does, though everybody's economy's dampened or worse. We're predicting still that within 10 years we're going to have a deficit of somewhere between 2,500 and 3,000 megawatts of generation. So we're facing load growth, a shortage of generation, our transmission system's constrained, most of our distribution assets are also near capacity. So we have a very large capital investment program in our 10-year plan, approaching $20 billion over the next 10 years, or about $2 billion a year of investment, primarily in, at this point in time, wind and natural gas generating resources. Well, the challenge for us, not only to meet our obligation electrically, is the fact that if you look at our average generation cost today, it's just under 4 cents per kilowatt hour. So if you're a residential customer somewhere and you look on your bill, or one of our customers, the electric energy they're paying for, it's about 4.5 cents, because we get 20% of our energy on the market that's more expensive. Well, since our fleet, our coal fleet on average is about 30 years old, and we've only added natural gas, you can see that any new resource that we bring online is going to be more expensive than the existing resource. So one of the problems we have, and one of the reasons you'll hear me talk so much about energy efficiency and demand reduction, is that that's less expensive than most of these central or supply side resources. So we have a very extensive demand side management and energy efficiency program in our company, really to help prevent us from driving customers' prices too hard as we respond to our growth. One of the other interesting things that we're facing, I'll elaborate on, is that the Energy Information Administration indicates that even as recently as last year, that there will be an increased use of coal-fired generation in the country. So right now we receive 50% of our electric energy in the United States through coal-fired generation, about 20% through nuclear electric generation. And as the country continues to grow, and the forecast is up to about a 40% increase in electricity consumption by 2030, we have this array of supply-side options to look at. So even though there's all of this discussion about climate change, reduction of CO2, a large coal-fired, pulverized coal-fired generation plant is the single largest emitter of CO2 in the industrial world. The Energy Information Administration still indicates some continued use for coal, which is almost antithetical to what you're hearing in the policy discussions in Washington and the various states. Not sure how that's going to get reconciled in the end, but that's one of the challenges we have as a company. The other thing we have to think about, and I'll elaborate on this as well, is how many people in here believe that a data center that runs less than 7 by 24 is a very valuable asset. So we have about 5 data centers who are thinking of relocating in the state of Utah, and I'm pretty sure that after talking to 2 or 3 of them, they want their lights on all the time, and they don't want some variability or intermittency in that supply. So if you look at the different supply options we have as a company or an industry, you'll see that there are only 2 or 3 true baseload dispatchable resources. That'll be coal, natural gas, and nuclear, and to some degree geothermal. And all of the rest of the options we look at, to some degree, lack that ability to dispatch, which means that we have a hard time meeting our 7 by 24 obligation to serve. So as we think about how we fill that hole, we have to take into account what are the options that we'll have electrically and from a policy perspective and economically, and how do we add those into our portfolio to meet our load requirements. One of the other things we find is even within renewable energy sources, there is a great deal of variability about their economics, and their economics are driven by 2 or 3 things. One, their capacity factor, and 2, their location or proximity to where the load is. So one of the other issues we're facing in a very big way, particularly in the western United States, is we have a great deal of solar potential, some geothermal potential, and some wind potential, but very little of that potential is located next to where we all live or where our industrial customers do business. So that means there's an extensive at least today, transmission capacity upgrade requirement to make any of this work. Now, I've often wondered if I could channel somebody or invite somebody to come to dinner. I don't know if you've played this parlor game. If you were holding a business, if you were holding an intimate dinner, who would you invite? And I'm sort of always thinking Abe Lincoln and maybe Willie Mays. And the third person I'd like to invite is Nikola Tesla. And the reason I want to invite Nikola Tesla is because his Tesla coil, he claimed, could transmit large volumes of electric power through the ground without transmission lines. If that were actually the case, my life would be a lot easier. So I'm trying to see if we could get Nikolai back, or at least find those lost papers of his that describe how he actually did that. But as you can see, we have some pretty good wind in the west, but even a 1% change in the capacity factor results in about a 2 cents per kilowatt hour cost. So if we're at 4 cents per kilowatt hour, you can see that a 1% change in the capacity for wind has a pretty distinct impact on our prices to customers. So if you start looking at these other options, as I said, the bulwark generators for the nation today are nuclear and coal. But these have their challenges. There's a lot of issues around nuclear power. We tried to permit a power plant in Payette, Idaho, a new nuclear plant, the first greenfield plant that was proposed in the country. We went down that path quite a long way, spent about $15 million. Estimated it cost us about $50 million to finish getting that license. And we decided, because we couldn't get a construction company or a technology vendor to sign up to any performance factors, that we had better back off of that. So even though we were going to spend, we thought about $50 million to try and get a license, we concluded that the industry actually really wasn't quite ready to make that commitment. One of the things about being owned by Mr. Buffett is when somebody says, send us $100 million a month for 6 or 7 years and maybe you'll have a nuclear plant, it's kind of not the sort of investment that he made that got him where he got today. So we stepped back. We still think there has to be a place in the portfolio for nuclear power going forward, but as you can see, there are issues. And of course, coal-fired pulverized coal generation that we currently use without carbon capture and sequestration has its own set of issues. Not only do you have CO2 emissions, you have other criteria, pollutants, and lots of unproven technologies. One of the other things we did was to explore putting an integrated gasification combined cycle plant in Rock Springs, Wyoming at our existing Jim Bridger plant. We spent about $6 million on a front-end engineering and design study and concluded that the cost per megawatt hour of output was going to be about twice that of a regular pulverized coal plant. And again, as an electric utility, we're spending our customers' money, and we didn't think that was a prudent thing to do based on that information. One of the other things that shocked us a bit was that we concluded that the carbon capture industrial island and the sequestration pumping and aggregation was going to reduce the output of the plant by about 30%. So not only did you have a very large capital cost increment, you also had a reduction in the overall capacity of the plant. So we decided that that technology wasn't quite ready for prime time yet. And as you know, in a policy perspective, clean coal technologies, new gen and some other things, future gen, excuse me, have been proposed, but nobody's driven them through yet. So there's not a place that we're aware of on the planet where you can go see a pulverized coal or even a gasified coal plant that takes the output of that and sequesters it. So all of the pieces and parts are there, the technologies are all proven, but they're not proven in an integrated fashion at utility scale and price. So even though we've looked at those very carefully, we've concluded those aren't the things we should do. Other thing driving our business are something called renewable portfolio standards, which indicate that a certain percentage of your electric energy must come from renewable sources. And generally those are defined as solar, concentrating or photovoltaic, wind, biomass, small hydro, combined heat and power. And so we as a company who deal at the West Coast with Oregon, Washington, California, and in the mountain states are having to meet some of these renewable portfolio standards. Clearly, our company, which also has a sister utility in Iowa, Mid-American Energy Company, believe that the best way to do this, if we're going to do it as a country, is to have a national set of standards, because right now there are distinct and profound differences in each state about what they're trying to accomplish, and then that makes our job just all that much easier, primarily from a bookkeeping perspective. So if you're familiar with what a renewable energy credit is, some states you get to keep them, some states you have to surrender them, some states don't care. In the meantime, we're trying to figure out how to meet all of these requirements across these states. Having said that, as I mentioned, we have some of the best wind power in America. In fact, the state of Wyoming has 50% of the class 6 and 7 wind sites, which are the most economic, though they are located in Wyoming. Wyoming is a state bigger than Utah and has about 500,000 people in it, so it's pretty sparsely populated, but lots of wind. And maybe the wind's part of the reason it is sparsely populated, because when I was a lineman, I hated nothing more than to get on a pole and have the wind blow, pole wave, you'd get vertigo, and the next thing you'd know, you'd think the wind was just a pain, and now all of a sudden it's become a resource. So there's sort of a land rush to wind development as well. Well, our company it has a lot of experience, starting particularly in the state of Iowa, with wind generation. And this is our profile for the amount of wind generation we have in our plan over the next few years. And we did just surpass the 1,000 megawatt threshold last year, and we have several other projects planned or underway. And one of the things to note is that Mid-American Energy Company, our holding company that has both Mid-American Energy and Pacific Corp Rocky Mountain Power, is the single largest owner-operator of wind turbines in America as a utility. So we have a great deal of experience in wind. We're bullish on wind, I guess to mix a metaphor. Maybe we should say we're eaglish on wind or something like that. But so one of the things that Craig Quist will be able to talk about later is the challenges we're facing as we try to integrate all of this wind into our system. And again, trying to respond not only to what we see in the policy world, but how we see our industry evolving going forward. And then this little blurb just confirms what I said. And our company, Rocky Mountain Power Pacific Corp, would be the second largest owner-operator. Now, there are utilities that provide more renewables to their customers, but they buy it from a third-party source. So just to be clear, this is really about an electric utility owning and operating wind projects. Well, I talked a little bit about the wind capacity attributes based really on how well the wind blows. The highest capacity we've seen on our system, somewhere around 44% on a monthly basis, not over the course of a year. Our average capacity in the Rocky Mountain Power area is about 36%, in the Northwest 31%. So if you remember what I said about 0.2 cents per kilowatt hour, it's almost another cent per kilowatt more expensive in the Northwest than it is in the Rocky Mountain Power states. The other interesting thing is the wind blows primarily at night and in the winter, and the output can change rapidly across broad geographies. There's some notion that if you get a broad enough geography, there'll be enough diversity in the wind generation that you can get some sort of capacity credit for it. We're finding that that isn't happening yet. Now, a lot of our projects are relatively new, so I don't want to make declarative statements about it, but it is the case that we're finding that it is difficult to predict the wind in any level of certainty. In fact, we've even gone so far in our company as to think about putting some buoys out on the Pacific Ocean coast in Oregon and our own weather stations across the West as we try to track the weather coming in, so we can do a better job of predicting what we think the output of these plants are going to be, because that's very important if we have to cover the shortfall in the market, or we have to change our dispatching of our existing fleet in order to cover the variability in wind. So we're spending an awful lot of time on this activity. But the other bottom line issue for us is, if you look at the chart on the left, you'll see that in 2006 there was a heat storm in California. The top black line indicates what the daily peak consumption was in the state of Wyoming, or excuse me, in the state of California. And the blue line shows the output of their wind projects. So when they needed the energy the very most, the capacity output of their wind farms was about 5%. So the other problem with wind is it's at its most valuable when we need it the least. And so it's something that we have to figure out, well, how do we integrate wind and yet still meet that sawtooth chart there on the right? So big challenge for us. Because I'm talking to a bunch of engineers, I did gratuitously throw in a couple of engineering-oriented slides, even though I don't know anything about it really. Yes, so I needed to play to the crowd a little bit, but well, I guess I did actually start in our company designing substations, so I probably could actually design the wind farm topology. But one of the things you find, there's a lot of issues with wind about harmonics and ramp rates, and the power conditioning is actually much more complex than you might think. And so I think that's one of the things Craig will be able to mention. And as we build more of these wind projects, we're starting to get some expertise, but we're also learning a few things on the job through the School of Hard Knocks about how this all works. So even though it seems pretty simple, it turns out that nothing's quite as simple as it seems. And again, another gratuitous slide for you control systems engineers to let you know that the controls on these wind turbines are highly sophisticated. And the mechanical analysis, the materials management type activities related with these wind projects is getting more complex and more sophisticated all the time. So not only do you have the physical energy reality of integration and bringing multiple windmills together, you also have to start thinking about how do you manage each turbine as an independent power source, because you can vary the pitch and yaw and direction of the nacelle on these turbines. How you then integrate that into your planning software and your next day economic plans is all very complex actually, and I think most entities are just barely learning how to deal with it. You've probably heard a couple times in Texas, they've had huge drop off in wind speed, and have at times had to curtail industrial customers, and a lot of that was a direct result of the industry not really knowing how to deal with a project, a huge amount of wind in the portfolio. So lots of opportunities there. On the solar side, you'll have remembered, I think, on the slide I showed you, that this is still the most expensive resource. It does have lots of opportunity and lots of upside, but we're finding that the photovoltaic capacity factors are only about 20%. And I was told, and I won't name names just because I haven't been able to verify the information, but a 10 megawatt solar photovoltaic solar project in Utah has really had a capacity factor of about 9%. So less than 1 megawatt on average coming out of a 10 megawatt asset. That's quite expensive. Also, if you talk to the Renewable Energy Lab in Boulder, you'll see that there is a lot of fluctuation on photovoltaic, and you lose more output than you might presume would be possible just by high wispy clouds or dust or other things. So again, this is going to happen, and maybe concentrating solar is the right answer. There's a lot of money in the stimulus package to continue to improve the efficiency and costs of solar power, and we are trying to put together a fairly large solar project ourselves, if for no other reason to get some experience, because we fully expect solar power to become another piece of the portfolio. But again, you have the intermittent nature, and I'm pretty sure that solar power doesn't work at night. I probably don't need to have an engineering degree to understand that, but so again, we have this whole issue of how do we give you a 7x24 service. As I mentioned earlier, particularly when you're talking renewables, but even if you're talking fossil fuels or nuclear, right now the transmission grid is near capacity. And in fact, most of the Western Electric Coordinating Council is predicting that their safety margin, if you will, is below prudent levels within the next couple of years. So it's very important that we beef up the transmission grid with new lines and frankly, new operational regimes and perhaps new technologies. But because we're growing so fast, we concluded that we needed to enter into a large transmission build program. And so we have proposed building about 2,000 miles of high voltage transmission, 230 kV and above. Well, there'll be some 345 kV and 500 kV in there. And we'll build a line from one of our best wind sources over near Casper, Wyoming, Glenrock, Wyoming, all the way to the west coast, probably southwestern Oregon eventually, and a couple of lines off of there, one out of Downey, Idaho into Salt Lake City, and then another line out of somewhere near Rock Springs, Wyoming, down into the Las Vegas area. And all of that's really meant to allow us to move not only our own generation, but market generation back and forth across the grid. So it's a very challenging thing. In fact, it's the hardest thing we do, perhaps, and I think I can demonstrate that. How many people in here would like to have a transmission line in their front yard? Though these are future leaders of America right here. In their backyard. A couple could stand it in their backyard, in their neighbor's yard. Interestingly enough, every time we try to site one of these things, there's almost a life cycle it goes through. First off, you don't really need it. Well, we've been able to demonstrate pretty clearly we need to do this. But secondly, you don't need it here. And so there are many criteria we have to balance. So we have to balance the impact on the environment from a visual perspective, on species, flora, fauna, antiquities. The next thing that happens, people will talk about property values being lowered by transmission lines. In fact, any of our facilities, even though we've studied it many, many times, we find that there's no direct correlation that's measurable. Then you get into the safety issues around EMFs, even though we continue to point people to websites that educate them that say it's not really an issue. And it's really come home to me personally because we're trying to upgrade a line from 46 kV to 138 kV, Salt Lake City. Well, the line runs right in front of the school where my daughter goes to school, and the principal called up and said, how could you possibly put my students at risk? And I said, well, my daughter lives there and goes to school there, so it's not likely if I thought that were the case, I would update that line. But it is kind of a cycle we go through. Then there's the environmental impact studies and all of the things that we're required to go through as a company. And now the Western Electric Coordinating Council, Electric Council, has said you can't have both of your lines in one corridor for reliability purposes because of the outages that took place back east. And then you have a bunch of landowners in these states saying, well, we don't want to have multiple corridors in the western United States. You need to put them all in one place. So then you're running the risk of making $6 billion investments and having them be derated 30, 40, and 50%, which completely destroy the economics of your investment. So lots of things that go on in our business that most people aren't aware of. And there are Federal Energy Regulatory Commission mandates, North American Reliability Corporation mandates, state mandates. And to get one of these things built, I think, is actually fairly miraculous in this environment. And I think it's one of the fundamental things that our country needs to figure out, because I submit that one of the reasons our country is great, it isn't just because of people like you, our can-do spirit, our history, our form of government. It happens to be because after World War II, we built the best infrastructure in the world across our country. So that's transmission systems, waters, the interstate highway systems. Well, they're not, I mean, anybody in here think that infrastructure is a sexy word? Well, nobody wants to spend money on infrastructure. They just sort of expect when you flip the switch, the lights are going to come on, or if you need to travel somewhere, the road will be good, or if you turn on your tap, the water will be there. Well, we haven't really attended to our infrastructure to the degree we should have over time either, and our electric infrastructure, with its growth and use, is probably the one under the most challenge right now. The other thing to remember is there is no modern society without electricity. I think electricity was viewed as the second most important invention, if you will, and I don't know whether it was Edison, Siemens, Tesla, or Westinghouse, but one of those geniuses gets credit for that. And there's no modern society without electricity. So if we were holding this today, we would be outside on the commons somewhere, and I'd be doing finger puppets instead of PowerPoints and a song and dance, and we'd be writing things on a piece of paper. Nobody'd be connected wirelessly. In fact, there's a direct correlation between gross domestic product and electricity consumption. So when I say one of the most important things in our society is you, I say that without reservation and very seriously, because you are the people who will continue to help us deliver on modern society. I've talked a little bit about some of the challenges, not in my backyard, policy changes. Costs were skyrocketing in our business until the economic turn down, because we were competing with India and China for things like steel, concrete, fuel. That's moderated some, but at some point we'll come out of this economic malaise and we will again be competing on a global market. There are very few, if any, domestic manufacturers of high voltage electric equipment anymore. In fact, I would probably still be working for General Electric if Neutron Jack hadn't decided that the part of the business I was in was number 3 and it needed to be shut down, which was high voltage equipment installation and delivery. And so it's another issue we have to think of, particularly from an energy security perspective, that most of the high voltage equipment we buy now will not be domestic. So as we think about climate change, that's the thing that's probably going to impinge the hardest on our business. We don't believe we're quite ready for significant CO2 reductions out of our fleet at least. We generate about 2/3, a little less than 2/3 of our electricity from pulverized coal plants. As I said, it's one of the largest, if not the largest, point source for CO2 in modern society. But we do think that we can get there, but we need to do a few things first. We need some regulatory reform. We need to decouple the sort of basic charges of our business, so like tree trimming, meter reading, maintenance of our facilities, from energy use. Right now, that's all, in our company at least, put together in a place. So we wind up having to have enough revenue in order to cover all of our other operating costs, even though that's counter to probably focusing on energy efficiency. We do have to support renewable or demand reduction and energy efficiency programs beyond anything that the nation's done before. Again, there are some regulatory issues there, but there are also some technology issues. As I mentioned, transmission is almost impossible to build. Somebody needs to be the prow of the icebreaker and fix that. We spent a lot of time in Washington, D.C. with congressional aides and the President's office, governors. And frankly, we think that just as there was some money put in a stimulus package for some clean coal technologies, if we're really going to make a dent in CO2 emissions and maintain some level of the same economic vitality we have today, this is an issue that we think needs to get fixed. We don't think you should implement a cap and trade program until you actually can reduce CO2 and have something to trade. So that's our company's position. Because if you start to think about how to regulate under cap and trade, today there's nothing to trade really. I mean, we don't know how to do it. The only thing we had planned was to reduce the CO2 emissions out of our coal fleet by putting in more wind. And then somebody said, hey, you don't run that generation at night, that's why you do lights, so why don't we go ahead and start plugging in hybrid electric vehicles into your system at night? Well, we were thinking, well, at night we'll back down our coal plants, reduce our CO2 emissions, and now if somebody says, well, wait a minute, we want to use hybrid vehicles, we lose that opportunity to reduce our CO2 emissions. So there's some inconsistencies, I think, about how people are thinking about how the grid really works. European Union cap and trade experience, there were some big fluctuations. I think people would say too many emissions credits were allowed to be issued to the various participants in that. Cap and trade really does kind of hide the cost of things because it's between trading amongst people. And those of you who understand what credit default swaps are basically financial instruments to protect yourself from failures in your bond market, will really like how cap and trade works between energy traders at banks instead of utility executives who want to keep your lights on and still meet the environmental requirements. Having said that, if we can get to cap and if we can figure out ways to reduce our CO2 emissions through technology, cap and trade is something we'd support, though we would like Congress and others to think about a cap so that we don't continue to emit CO2 and then put a tax on it, again, as an incentive. And I can't emphasize this enough. We are managed by something called public service commissions. So we actually are a public service. And whether you're a co-op or a rural electrification or an investor-owned utility or municipality, the fact is all of us have a stewardship responsibility for our customers and the environment. And when we talk to people, our focus is about our customers, because in the end, perversely, the way we make money is through capital investment. So if somebody says you have to change all of these power plants out and put in new ones, we actually make more money. So it isn't an issue for us. It really is what can society absorb as price increases related to what we do. Magnitude of our problem, we emit about 80 million tons of CO2 a year. And if we don't figure out a way to reduce CO2, the blue line indicates right now our portfolio additions are primarily going to be natural gas and wind. So even if we put in if we never put in another coal plant, our emissions are still going to rise. And if you look at the reduction in 2050, which is essentially the Lieberman-Warner reduction, somewhere in between that blue line and that purple line, I like to say magic happens, because I don't know how to figure it out, but you guys may be able to. But that's a physical reality challenge we have as a company. And to put a little bit of a flavor for what that's going to cost, our oldest coal-fired generating plant's 173 megawatt plant in Helper, Utah. If you were to replace the output of that plant based on its current cost, and these are reported in our FERC Form 1, it will cost us $50 million a year for our smallest plant. And to replace the capacity, you would have to have about half of the wind we put in the last 2 or 3 years just to provide the electricity out of our smallest coal plant. So again, these are issues I don't think get a full hearing. There's a lot of discussion, well, we can go to renewables, there'll be no price increase, there will be no real issues. Well, these costs don't include the integration cost to make it 7x24 or any transmission interconnection costs. So again, as we think about impacts on our customers, the way we have to plan, it is about the reality of today and tomorrow, even though we know these investments we're making can have 50 and 60 year lives. Last thing I'd say is, as informed citizens, even if we have very strong beliefs about the right things to do, we wind up kind of in the nexus of inconsistencies or incompatibilities or single item advocacy, in that our public service commissions expect us to come up with the lowest price electricity that can be risk adjusted, that's safe, reliable, and affordable. And that's how we're managed. All of our decisions are based on a prudency test, and those prudency tests are primarily about what does it cost customers. So we have a lot of pressure on our regulatory framework there, and yet, particularly in the state of Utah, where we've been very successful at it, Governor Huntsman and his Office of Economic Development is very good at bringing in new load. Data centers, as I mentioned, that can be anywhere from 50 to 100 megawatts. Well, that's driving that demand for electricity up. You saw what the price impacts are going to be, either through policy or just the fact that everything costs more now than it did 30 years ago. And so we have this desire to have jobs and a strong economy, which I think everybody's for. And in fact, I'm even for it. I'm the vice chairman of the Economic Development Corporation of Utah, which is a private-public partnership to spur economic growth. And then finally, you have the environmental requirements that we have. And frankly, they need to be there. So we're not suggesting that we be relieved of the duty to maintain the stewardship of the environment, particularly in that our assets are everywhere. So if you have AC connection to some sort of utility, you have some of that utility's asset in your backyard, front yard. We talked about transmission lines, power plants. So we know we have an obligation to do our jobs in an environmentally responsible way. But those environmental advocacy positions sometimes say no coal, no nuclear, only this, that, and the other. So in a way, we're kind of caught in the middle of three forces, the three E's as I call it, that I think if we're going to make this a successful transition to a new economy, greener resources, we're going to have actually have more candid conversations about how you make these things internally consistent instead of taking that, well, we have to bulldoze all the coal plants today. Well, that would be a disastrous outcome for our economy, irrespective of what others might say. And I know that this is maybe a little bit of an arrogant sounding statement, but I've almost concluded our ability to influence things are inversely proportional to our expertise, our experience, and our actual responsibility for what goes on in the world. But I can tell you, we'll do our best to meet society's requirements and requests, but it's going to be a challenge for all of us. So what's the great thing about this organization? Well, you are, as we say, right at the coal face, though I can't say that anymore, I guess. I should say you're right at the turbine blades of what's going to happen in the electric industry going forward and in society. Aging engineering workforce, I kind of gave you a hint about my vintage. I'm towards that vintage that isn't going to be here for that much longer. So we have really worked hard recently working with Mark Dodson and Doug Benyon, who's in the back of the room, who's our Vice President of Engineering and Construction, to develop a better relationship with the local universities. In fact, I was in the last graduating class from the University of Utah that had a power engineering emphasis, and that's gone away. And we've been able to work with Mark and the University of Utah to establish a chair for electrical engineering, and we're delighted to say that we were able to hire 10% of the graduating class from the University of Utah's electrical engineering program. So not only do we have people with great experience like Doug and myself and Craig and others, we've recognized now that the future of our business in lots of ways really does lie back with our electrical engineers. And for a while we were in stasis because one of the tests I'd give is, who in here knows who Henry Miller was? Not the author. For those of you who know that Henry Miller was a notorious author in the 50s, but not that I ever read his stuff, I just read about it in other magazines. But Henry Miller started the International Brotherhood of Electrical Workers, which is the union I belong to, over 100 years ago. And one of the things I always say is that you could take Henry Miller out of the ground, dust him off, send him towards a pole, and he'd know how to do the work. Because the fact of the matter is the big end of the pole still goes on the ground and the wires still go on top. And the transformers, distribution transformers, have changed very little in the 100 years since they were first conceived. I mean, there's some new materials in the cores. They know how to wind things better. They know how to balance the cooling with the insulation better. But the fact of the matter is, most of what we do today, Henry Miller would recognize. He'd know what a transmission line is. He'd know what a transformer was. He could use most of the tools that our linemen use, though he would have used mules and pike poles, where our guys use mechanized equipment. We have electric facilities that are over 100 years old still delivering power to our customers in some of our hydro facilities. So it's pretty amazing, our business. We have that much tradition and knowledge, and yet we're on the vanguard of change. I think the biggest opportunities for people in our business are, how do we integrate all of these multiple resource profiles into the grid so we maintain grid reliability and capacity? I think we've just started to scratch the surface of how we use IT in our business. I think we are actually on the forefront of that in some of our thinking, taking information out of our energy management systems, our distribution operations systems, power plants. There's going to be a lot of new technology come out, whether it be self-healing adaptive controls. I read that somewhere. I don't know what it means, but it sounded pretty impressive for a group like you guys. But it's like we're going to use artificial intelligence to have the system be even more robust, get more capacity out of it, make sure it's more efficiency. We need to start sending different pricing signals to our customers so they have a choice as to when they operate their equipment. Load controls. We, for instance, looked at something that reduced the voltage on fluorescent lights enough that it would allow the lights to still operate but reduce electricity consumption. It works only for certain types of lights, so we abandoned it, but that's the sort of things we're looking at. We have a air conditioner control program that doesn't change your thermostat, but just doesn't allow all of the air conditioners in a certain geography to run concurrently or simultaneously, so it lowers our peak demand. It's a very effective program. But we've just barely started to scratch the surface there. Distributed generation, smart grid technologies, plug-in hybrid vehicles, all of these things give us a great deal of opportunity as people in our business. Improved electric efficiencies, and I think in the end, I'd exhort you all to really think about your jobs in a spirit of innovation, creativity, commitment to that public service. Because again, without us, the people in this room and those like us, the electric industry isn't going to deliver on what it needs to deliver on for the country's, I guess, just overall health and well-being. So I can't tell you how much I appreciated the opportunity to welcome you to Salt Lake, and thank you very much.